Every night, your brain builds a world detailed enough to feel completely real. You walk through it, you talk to people, you feel emotions, you experience adventures. By the time you reach the sink in the morning, it's gone. Like smoke through your fingers, the entire world your brain just created vanishes within minutes, sometimes seconds. Most people assume this is just a simple memory problem, that dreams are too hazy or unimportant to remember. But scientists have spent decades trying to explain why the same chemistry that generates your dreams disables the system that would record them. And the answer is stranger than anyone expected. In 1953, researchers at the University of Chicago made a discovery that changed everything. They observed that about an hour after people fell asleep, they experienced a burst of rapid eye movement under their closed lids, accompanied by brain waves resembling those of an alert waking person. When they woke people during this REM sleep, they recalled vivid dreams 20 out of 27 times. When they woke them during non-REM sleep, they recalled dreams in only 4 out of 23 instances. The connection was clear. REM sleep is when your brain is most active, when it's creating these elaborate experiences. But why does it also make them so hard to remember? The answer lies in a chemical called norepinephrine. During REM sleep, the levels of norepinephrine in your brain drop dramatically. This neurotransmitter plays a huge role in memory formation during wakefulness. It helps you encode and store experiences. But during dreaming sleep, it's almost completely absent. Think of norepinephrine as the save button for your memories. When you're awake, it's active. It helps you record what's happening. During REM sleep, that button is disabled. The processes that allow you to create long-term memories largely lie dormant while you sleep. So your brain is running on a different neurochemical environment, one that's fantastic for generating bizarre narratives, but terrible for saving them. Without that memory anchor, your dream experiences simply don't get transferred into lasting memories. Now, here's where it gets even stranger. Some researchers believe that forgetting dreams isn't a flaw, it's a feature. Imagine if you vividly remembered every bizarre dream scenario with the same clarity as actual memories. You'd struggle to distinguish reality from fantasy. Your brain would be cluttered with false memories of flying, conversations that never happened, and events that seemed real but weren't. The brain may actively want to dump this information. There's a group of neurons called MCH neurons that help the brain actively forget new, possibly unimportant information. Since dreams are thought to primarily occur during REM sleep, activation of these cells may prevent the content of a dream from being stored in the hippocampus. Consequently, the dream is quickly forgotten. It's not a glitch, it's a design. But here's the crucial detail. If you wake straight out of a dream, you have a much greater chance of remembering it. As your brain awakens, it starts to turn on the processes needed for long-term storage. The norepinephrine returns. The save button comes back online. That brief window between dreaming and waking is your only chance to capture the experience. This is why the people who remember their dreams most often are also the ones who wake up more during the night. In 2014, a team led by INSERM researcher Perrine Ruby at the Lyon Neuroscience Research Center made a fascinating discovery. They used PET scans to measure brain activity in high dream recallers, people who remember dreams 5.2 mornings per week, compared to low dream recallers, who remembered only 2 dreams per month. The high recallers had stronger spontaneous brain activity in the temporoparietal junction and the medial prefrontal cortex, areas involved in attention orienting toward external stimuli. In other words, their brains were more reactive to their environment. They woke up more often during the night, and those brief awakenings gave them the chance to encode their dreams in memory. This may explain why high dream recallers are more reactive to environmental stimuli, awaken more during sleep, and thus better encode dreams in memory than low dream recallers. The same research team followed up with another study in 2017. Raphael Vallat and colleagues found that while neurochemical changes explain a lot, individual differences in brain structure also matter. High dream recallers showed greater functional connectivity within regions involved in memory processes, including the default mode network, the brain's daydreaming network. This suggests that some people are simply built to remember their dreams better. Their brains are wired in a way that makes dream recall easier. But there's another factor. Giulio Tononi, a researcher at the University of Wisconsin, has proposed what's called the synaptic homeostasis hypothesis. His theory suggests that sleep is the price we pay for brain plasticity. During the day, your brain builds up new connections. They strengthen, they multiply. During sleep, your brain scales those connections back. It cleans out unnecessary traces from the previous day by shrinking brain synapses and clearing space so more can be learned. Tononi and his colleague Chiara Chieri found that just a few hours of sleep shrinks synapses by about 18% on average. This downscaling is essential for learning and memory, but it also means the specific neural patterns that formed your dreams get pruned away. They're part of the information that gets cleared out. Sleep is fundamental for the brain to function, learn, and remember, and to forget, which is just as important. So why do you forget your dreams? It's not one thing, it's a combination of factors. First, your brain chemistry during REM sleep actively prevents memory formation. Norepinephrine is suppressed. The save button is off. Second, the synaptic downscaling that happens during sleep prunes away the neural patterns that formed your dreams. They get cleared out to make room for new learning. Third, if you don't wake up during or immediately after a dream, you never have the chance to encode it. The dream ends before you wake, and the memory never forms. And finally, if you do wake up, you're in a race against time. Anything that captures your attention immediately after waking interferes with dream recall. But here's the good news. There are techniques that can dramatically increase your dream recall. Just as you are falling asleep, keep reminding yourself that you want to remember your dreams. Let it be your last thought as you drift off. Keep a notepad and pen by your bed. When you first wake up, don't jump up. Don't turn your attention to anything else. Even if you don't think you can remember a dream, take just a minute to see if there is any feeling or image you can describe. Following these simple steps may cause an entire dream to flood back. The more you practice, the better you get. The reason for dreaming is still a mystery for researchers. Why does your brain create these elaborate worlds only to immediately forget them? Maybe forgetting dreams isn't a flaw, but a feature, keeping your waking consciousness uncluttered and reality-focused. Every night, your brain builds a world detailed enough to feel completely real. Every morning, that world disappears. And the reason why is one of the most fascinating mysteries in all of neuroscience. Thank you for watching.